Managing ADHD often involves a difficult trade-off. Patients may achieve intense, rigid focus for a few hours, only to be met by a sudden, jarring crash as the medication leaves their system. This line graph illustrates the pharmacokinetic flaw in standard immediate-release stimulants. They flood the bloodstream almost instantly, creating a rapid spike in concentration, followed by an equally steep decline. That sharp peak is tied to high abuse potential, while the decline triggers the clinical crash. To address this volatility, researchers developed Lisdexamfetamine, known commercially as Vyvanse. It was designed to bypass the traditional pitfalls of stimulant delivery by altering how the drug interacts with human biology. The molecule is a prodrug, a pharmacologically inactive substance. The active stimulant is chemically bonded to an amino acid, which means that in its raw form, it cannot bind to dopamine or norepinephrine receptors. If the drug is crushed, snorted, or injected, it fails to produce a faster effect. Because the molecule requires a specific biological process to become active, the effects remain constant, regardless of how the drug is administered. Scientists engineered a compound that remains pharmacologically silent until it encounters the specific enzymatic environment of the human circulatory system. After the capsule is swallowed, it moves into the small intestine and is absorbed into the bloodstream via active transport. Even at this stage, the drug has no effect on the brain. The transition to an active state only begins when the molecule reaches its primary checkpoint, the red blood cells. Inside red blood cells, specific enzymes cleave the peptide bond, separating the amino acid from the active stimulant. This hydrolysis acts as a built-in speed limit. Cells process the drug at a metered rhythm, making it impossible to activate the entire dose at once. This chart in the pharmacokinetics panel shows the result of that slow activation. The drug reaches its peak concentration gradually, typically between 3.5 to nearly 4 hours after the initial dose, maintaining a smoother presence in the blood. This mechanism effectively uses the patient's own red blood cells to regulate the delivery of the medication throughout the day. Once the D-amphetamine is freed into the plasma, it crosses into the brain to begin its work on the central nervous system. It functions by blocking the reuptake of dopamine and norepinephrine, while also encouraging the release of these neurotransmitters into the spaces between neurons. This increase in neurotransmitter availability helps stabilize neural pathways associated with ADHD, leading to reduced impulsivity and a more sustainable level of focus. Beyond ADHD, Lisdexamfetamine is the only stimulant indicated for binge eating disorder in adults. Doses of 50 to 70 milligrams help reduce binge episodes. However, note the specific limitation. It is not indicated for weight loss, and its effectiveness for obesity is not established. Researchers are investigating this steady release model for other conditions, including cognitive impairment in multiple sclerosis, executive dysfunction during menopause, and to treat stimulant use disorders. By engineering a slower delivery speed, pharmacologists have created a more predictable tool for neurological regulation. While the delivery is smooth, the substance itself remains a powerful stimulant, with effects that reach far beyond the brain. The common side effects row highlights the systemic impact. Nearly 40% of pediatric patients report a decrease in appetite, and significant numbers of users across all ages experience insomnia, dry mouth, and an increased heart rate. The medication carries a boxed warning due to its status as a controlled substance. Despite the prodrug design, there is still a high potential for misuse, addiction, and dangerous overdose. The stimulant effect can raise blood pressure and heart rate. In patients with existing heart defects, it has rarely been linked to sudden cardiac death. There are also psychiatric risks to consider. The drug can trigger manic or psychotic symptoms, even in patients who have no prior history of these conditions. Because of these systemic risks, the drug is classified as a Schedule II controlled substance. This designation requires strict oversight and careful monitoring of the patient's cardiovascular and mental health. For those who respond well to the treatment, the primary benefit is a consistent therapeutic effect that can last between 10 and 14 hours from a single morning dose. Lisdexamfetamine uses the body's internal chemistry to meter its own delivery. It achieves a more consistent therapeutic effect, provided the patient and clinician respect the potency of the underlying stimulant.